Okay, students, welcome back. We do have homework this time, so please don't think that you get away with not doing homework. We're back to it. We got homework. All right, this should be maybe something you did in your last chemistry class, maybe not. We'll have to kind of see, but hopefully it should be fairly easy. But we're going to get some background knowledge. But today, with our ionic bonds, we drew Lewis symbols. Today, we're going to draw Lewis diagrams, and these are all covalent compounds. So we're talking about covalent compounds kind of from here on to this rest of this unit. We're talking about covalent compounds. So we must first start with a single covalent bond. All right. So our covalent bond, our first single covalent bond is where we're talking about sharing of 2 electrons. So we're sharing 2 electrons. Some other items, some other words that we need to know, bonding pairs, these are the ones that are actually doing the sharing, right? A lone pair is focused only on one atom. It's only on one atom. There is no bond there, which makes sense, okay? And these lone pairs are called non-bonding electrons, all right? So these non-bonding electrons are obviously not bonded with another atom, all right? They are focused solely on one atom, okay? Then if we look at a double bond, this is where we're sharing 4 electrons. A triple bond, we're going to share, what do you think? 6 electrons, good, or 3 pairs, right? So, jumping in, ready to do this, here we go. Our first step in drawing Lewis structures. Woohoo! Our first step is to add up those valence electrons, and this is what we talked about when we did our valence electrons. I'm scrolling up, hopefully I'm not making people sick, but this little ditty right here, we're going to use those, all right? So taking it back down, here we are. Okay, so we add up our valence electrons for the compound. And if we have a cation, which means it's positively charged, we are going to subtract that many electrons. Man, my spelling. Subtract that many electrons. All right. If we have anions, that means they're negatively charged, we will add that many electrons based on the charge. If we have a +1, we'll take away 1. If we have a -1, we would add 1 electron. Okay, so that's step 1. Finding out how many electrons we're going to place is really what it comes down to. All right, then our second step is to draw our skeletal structure. And this is where we choose our central atom has to be our least electronegative element. Except it cannot be hydrogen. Hydrogen can't be a central element because it only has 1 bond or 2 electrons. Ooh, looks like we got a spelling error there, huh? Okay, so we can only have 2 electrons, so hydrogen will never be your central atom. It will always be a terminal one, but we'll kind of move on from there, all right? Our third step is to fill the octet of the surrounding atoms, and our fourth step is to fill the octet of the central atom. If we don't have enough electrons, we might have to do some double or triple bonding to give them octets. Okay? So those are our steps. Let's see if we can't keep rolling through them. So we got some examples here. Quite a few, in fact, or at least I think quite a few. All right, so we've got CH4. We're going to start with the first one, CH4, methane. And our first step is to add up valence electrons. So we look at carbon, it's in group 14. It has 4 valence electrons. Then we look at hydrogen, it's in group 1. Each hydrogen has 1, so we have 4 times the 1, giving us 8 valence electrons. So we can place 8 valence electrons. Our second step says to draw the skeletal structure. This is where we choose our central atom, and it's got to be the least electronegative one, so we're looking furthest away from fluorine, but it cannot be hydrogen, okay? It cannot be hydrogen. So we have to put C in the middle, and then we the skeletal structure means we just connect our outside atoms to our central atom, okay? And so if we look, each dash that I have drawn signifies 2 electrons. So I've now placed 2, 4, 6, 8 electrons, which is all I had, right? So I'm out of electrons, but is everybody's octet or duet filled? Yes, hydrogen each can have only 2, and then carbon has 4 or has 8. So everybody is full and happy. I know they can't be happy, but you get it, okay? So let's try CO2 kind of that same way. We have carbon, all right, which is 4. We have oxygen. We're going to take that 2 times. Oxygen's in group 16, so it has 6 valence electrons. So we've got 4 plus 12 gives us 16. All right. Next up, our next step is to find our skeletal structure, so we've got to put our central atom in there. Well, we've got 1 C and 2 O's, so I think C is going to be in the middle because it's the furthest away from fluorine. Okay, and we've got an O on each side, all right? Or wherever you want to place them. If you wanted to put them on top and bottom, that would work as well, okay? Now we've placed 4 electrons, 2 there, 2 there, 2 there, 2 there. All right, but now we need to place 16. So we fill the octet of our surrounding atoms. So we've got 2, 4, 6, 8, 10, 12, 14, 16. All right, so our oxygen's octets are full, but carbon's is not. So this is where we go to the last step that says fill the octet of the central atom. If unable to fill octet, form double or triple bonds to give them octets. So what we can do is we can remove these 2 right there and now make it a double bond. And now carbon, oxygen is still full and carbon is slightly closer. So let's do that on both sides. And so now everybody's octet is full. Carbon has 8 electrons around it. Oxygen has 8 electrons. Each oxygen has 8 electrons around it. And that would be our first one. Sometimes this is just going to take some practice. Okay, so let's roll on to the next one. We've got NH4. Okay, NH4. First step is we've got to find our valence electrons. So N is in group 15, so it's got 5 valence electrons plus 4 times 1. Now, this time we have that plus 1 charge. We've got to subtract 1 for that one. And now we've got 9 minus 1 gives us 8. So we're going to put N in the middle because hydrogen can never be the central atom. And then we're going to put our surrounding atoms around. And we've actually placed our 8. And guess what? We are done because our 8 are placed. The one thing that we also have to add on a charged or on an ion is we have to put the brackets around and show where that extra electron went. All right, so we put brackets around it and show where that electron went. All right, one more. This one's actually going to have, it's going to be a little more difficult, but I think we can handle it. So we now have 3 times 1 plus 4 for the carbon plus 6 plus 4 plus 3 times 1. So that's how many electrons we have to place. We've got 7 plus 6 is 13, 17, 20 electrons if I did my math right. Hopefully I did. All right, and this one's actually going to be drawn kind of like it looks. We have O, then we have a C and a C, and then let's put some H's here. Oh my goodness, how are we doing on this? Is anybody freaking out? We all right? Okay. Now, if we look at that, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 bonds. We have placed 16 electrons, right? But carbon is happy, but each oxygen, our oxygen is not quite happy. So we have some lone pairs that we can put out there, and we can put those lone pairs on oxygen. And look, now oxygen is full as well. Okay, see you next time.